Okay, this is lesson 3.6, exponential equations. An exponential equation is an equation that contains a variable in the exponent. So that means your x that you're solving for is actually going to be in the exponent. And the point of this entire lesson is to figure out how to find x when it's in the exponent. And there are a couple ways that you can do this without using graphing technology, actually using some algebra. So we're going to look at that, and the main one that we're going to focus on is making powers of the same base. And the reason why is if you have something to an exponent, like a to the exponent of m, and you have that equal to something a to the exponent of n, where the bases are the same, a and a, that means that the exponents would have to be the same. And this is called equating the powers. So for example, if we had 2 to the exponent x, and we wanted to find x, and it was set equal to 2 to the exponent 3, well then, it's pretty clear that x has to be 3. If these two things are equal, well, the bases are already equal, so that means the exponents must also be equal, which means x must be 3, equating the powers. So since 4 to the exponent x and 4 to the exponent 3 are both powers of 4, the exponent must be equal. So if the solution to the equation 4 to the exponent x equals 4 to the exponent 3, the bases are already the same, x must be 3. And we're going to take advantage of this concept when solving for exponents. Now, if the bases are the same right from the beginning, it's pretty easy. 5 to the exponent x equals 5 to the exponent 6. Well, bases are already the same. We can just say that x equals 6. It's when the bases aren't the same that it gets a little tricky. Like 2 to the exponent x equals 32. That's not 2 to the exponent something. So what we do is we change it to 2 to the exponent something. How do we do that? Well, we use our calculator. And it's dusty, I haven't used it in a while. And we try to figure out 2 to the exponent what is 32? Well, 2 to the exponent 3 is 8, that's not it. So we gotta go a little bit bigger. I'll put the calculator on the other side. That's better. Let's try bigger exponent. 2 to the exponent 4, that's 16, that's not it. 2 to the exponent 5, that's 32. So instead of 32, we can write 2 to the exponent 5, and now we've got the bases the same. So we can set the exponents the same. And it's basically like trial and error. But now if you know your powers of 2, it's not really trial, you're just writing the answer down. Let's try the next one. 2 to the exponent something is 1/2. So we're to think back to our exponent rules from previous lessons. It's been a while though, so I don't know how much thinking back we're going to do. Let's try to find that exponent just by guessing and checking here. 2 to the exponent something has to give us 1/2. Let's try some stuff. 2 to the exponent 2 is 4, that's too big. 2 to the exponent 0 is 1, that's closer to 1/2. Now, this one actually uses the negative exponent rules. If you remember negative exponent rules, that's how you get answers that are less than 1. Let's try negative 1. 2 to the exponent negative 1 is 1/2. So we can change 1/2 to 2 to the exponent negative 1, and now we can get an answer. X is negative 1. Now I'm going to teach you another way to do this, but this is the common base method. 2 more. 2 to the exponent something is 1/4. Well, we already know 2 to the exponent 0 is 1, and if we wanted to go into the negatives, That's how we can get numbers less than 1. So without a calculator, I'm going to tell you that 2 to the exponent negative 2 is 1/4. Which means, now that we have the same base, x is equal to negative 2. Because we can equate the exponents. Now e looks a lot more complicated. It's really not. 7 to the exponent something, that something's just a little bit more complicated than usual, is equal to 49. Same rule still applies. 7 to the exponent something is equal to, well, 7 to the exponent something is going to give us 49. And it's 2. 7 squared is 49. So instead of 49, we can write 7 squared. Now, since the bases are the same, we set the exponents equal. Three x minus 4 equals 2. And now we just have to solve. Bring the 4 over, we get 2 plus 4 equals 3x. 2 plus 4 is 6. Divide the 3 away. We get x, it's not really a very good equal sign, x equals 2. So same concept. Base is 7. This base isn't 7. Change it to a base of 7. Guessing and checking in your calculator. Once the bases are the same, make the exponents equal. 3x minus 4 equals 2. That's my next line. 3x minus 4 equals 2. Solve for x. All right, let's flip it over. Two more examples. How do you know which base to pick? If you have two things with exponents of x. We've got 3 to the exponent 5x plus 8 and 27 to the exponent of x. How do we choose which base we're going to make it? Are we going to make it 3? Are we going to change 27 to the base of 3? Or are we going to change 3 to the base of 27? Always pick the smaller one. So I'm going to write a couple steps over here on the right side. Steps to solving. Step 1, make bases the same. And what do I mean by make bases the same? I mean the smaller one. Smaller base. So let's change 27 to 3 to the exponent something. So we're not changing this side. We are changing 27. There's still an x out there. We want to make 27 have a base of 3. So 3 to the exponent something is going to be 27. 2, that's 9, so that's not 2. Let's try one bigger. 3 to the exponent 3 is 27. Now, are these all going to work out, always going to work out nicely? Fairly nicely. I might do like 0.5s, but it's usually just going to be a whole number or a negative number. 3 to the exponent 3. Now, this looks a little complicated, but it's just a power of a power. And if we think back to our exponent rules, when you have an exponent on an exponent, the math says to multiply. So again, I'm not touching the left side. 3 to the exponent 3 to the exponent x, we would multiply the 3 and the x and get 3x. So that's step 2. Once you make the bases the same, use exponent rules to simplify. After you've used the exponent rules to simplify, you can set exponents equal. So our exponents are 5x plus 8 and 3x. Step 4, collect like terms. So I got two terms with an x and a number term. I'm going to put all my x terms on one side and the numbers on the other. 5x, I'm going to bring the 3x over, minus 3x. Bring the 8 to the other side, minus 8. Now we're going to collect our like terms. 5x minus 3x is 2x. And we're going to divide by the 2. 2 divided by 2 is just x, and negative 8 divided by 2 is negative. And there's our answer. And if you check it, if you plug the negative 4 in, both sides should equal. Step 5, we forgot step 5. After you collect like terms, solve for x. Specifically, I guess, by dividing away the coefficient. The number in front of the x term. All right, we're going to follow those steps in H. So we got a base of 4 and a base of 8. So we're not going to change the 4. But we are going to change the 8. So 4 to the exponent something is 8. Let's check. 4 to the exponent 2 is 16. That's bigger than 8. So it's got to be something smaller than 2. But 4 to the exponent 1 is 4. So it's something between 1 and 2. Let's try 1.5. There it is. 4 to the exponent 1.5. So now we've got an exponent of an exponent. I'm not going to touch this side. When you have an exponent on an exponent, you multiply. But this, there's two things to multiply. The 1.5 has to multiply the 3x and the minus 2. So we can just rewrite that as this. It's going to multiply both things. And now the bases are the same, so we can drop them and set the exponents equal. Now, since we got brackets, we have to do a little distributive property. 2 times x and 2 times 4, 2x minus 8, and 1.5 times 3x is 4.5x, and 1.5 times negative 2 is negative 3. Collect our like terms. I'm going to move the 2x over, so we have 4.5x minus 2x. Negative 8, bring the 3 over, plus 3. We end up with 2.5x and negative 5. Divided by the 2.5. We get x equals negative 2. All right. This one, much more complicated, but it's the same steps. Make the bases the same, so pick the smaller number, guess and check to figure out what the exponent is. Use the exponent rules. Exponent of an exponent means multiply. Then drop the bases. Expand, collect like terms, solve for x. Okay, last example. A cross-country skier Forgets a mug of coffee and a muffin in a snowbank. Their temperatures in degrees Celsius after T minutes can be modeled by the formulas. Temperature of coffee is 81 times 3 to the exponent negative 2t. And the muffin, 27 times 3 to the exponent negative 1. Determine when the coffee cools to the same temperature as the muffin. So that's asking, where is the temperature of the coffee the same as the temperature of the muffin? Maybe about a week ago you didn't think you'd be doing a math question about the temperature of coffee and the temperature of a muffin. But here we are. Temperature of a coffee. Well, that's the 81 times 3 to the exponent negative 2t. And the temperature of a muffin is 27 times 3 to the exponent negative 1. Notice that there's only one variable in this entire equation. It's right there. So that means that this whole thing on the right side is just a number. So, well, we can figure out what the number is. 27 times 3 to the exponent negative 1 is 9. So now I have 81 times 3 to the exponent negative 2t equals 9. And what makes this left side so complicated is this 81 times. Well, the opposite of multiplication is division, so let's just get rid of the 81. And now, we've just got 3 to the exponent negative 2t, which looks a little bit more normal. 9 divided by 81 is just 1/9. Remember when I said pick the smaller base? Well, now we have 3 to the exponent negative 2t equals 1/9. If we want to solve for an exponent, we need to make the bases the same. 3 and 1/9 are not the same number. I said pick the smaller one. I suppose what I should have said was pick the smaller one when you have two whole numbers. If you have a fraction, you definitely want to pick the whole number. So we want to pick the smallest whole number for our base. So that means we're going to keep this term, 3 to the exponent negative 2t, and we're going to try to make 1/9 3 to the exponent something. Well, 3 to the exponent what would be 1/9? Well, 3 to the exponent 2 is 9. That's a whole number. We need a number less than 1, so we got to go into the negatives. So I'm going to try negative 2. And there we have our 1/9. So 3 to the exponent negative 2. Now the bases are the same, so we can make the exponents equal. So negative 2t equals negative 2. To get t by itself, divide away the negative 2, and we get t equals 1. So when's the coffee cool at the same temperature? 1 minute. Time is 1. Okay, so what's the point of this lesson? Well, the point of this lesson is for you to understand that if you want to solve for an exponent, you need your equation to have two powers that have the same base. No matter how complicated something looks, we can simplify it to get to a point where we just need to change the base. So we have the same base, so we can make the exponents equal so we can find an answer. And that's what all of these examples were. So that's it for 3.6 lesson. There are some practice questions that I assigned in your unit schedule. If you want some practice solving exponential equations, you should practice. Otherwise, you should continue to add to your survival guide, because at the end of this unit, we are going to have our Unit 3 test. So stay tuned for more details on that. And thanks for watching 3.6, and I'll see you in our last lesson of the unit 3.7.